This is problem 13 from the 2026 Chinese GaoKao. We are given f of x equals 2 sine of ax plus theta, where a is an integer and theta lies between 0 and 2 pi. We are told f is even and that it increases on the open interval from 0 to pi over 2. Find theta and find f of 3 pi over 2. Start with what even means. The graph must be unchanged when you reflect it across the y-axis. Here, f of x is the solid curve, and its mirror image, f of minus x, is dashed. Watch them as theta sweeps. At theta equal to pi over 2, the mirror lands exactly on the original. The function is even, and it happens again at 3 pi over 2. Algebraically, evenness forces 2 cosine theta times sine ax to vanish for every x. So cosine theta must be 0, which leaves exactly these two phases. The two phases give two different shapes, 2 cosine ax and minus 2 cosine ax. Positive cosine starts at its maximum, so it falls immediately. It cannot be increasing near 0. Negative cosine starts at its minimum and climbs, so theta has to be 3 pi over 2. Now the trap. The shaded strip is the target interval, 0 to pi over 2. This curve rises until x reaches pi over the absolute value of a, and then it turns over. At a equal to 1, that turning point is far off to the right. The curve climbs through the whole strip. At a equal to 2, the turning point sits exactly at the right edge, still increasing throughout the interval. But at a equal to 3, the peak moves inside the strip, at pi over 3. The function turns over before the interval ends, so 3 is ruled out. The condition is simply that pi over the absolute value of a is at least pi over 2. That leaves the absolute value of a equal to 1 or 2. So the first blank is pinned. Theta is 3 pi over 2. But two frequencies survive. If the absolute value of a is 1, f of 3 pi over 2 is 0. If it is 2, the answer is 2. The first blank is forced. The second one is not. As written, this problem admits two answers. So here is the habit worth keeping. When a problem tells you a parameter is an integer, test every integer it allows before you assume the answer is unique. More problems work this way at SciMigo.com and on the Thinking in Math YouTube channel.